Hello everyone, this is a question from GATE Metallurgy 2020-21 and it is as follows. Which one of the following elements oxidizes first in a basic oxygen steelmaking process? So it is asking which one of the following four given options will be oxidizing first. So for that, let us try to understand how we can pick this particular answer. So for that, we'll be using the concept called a lingam diagram. So how a lingam diagram is actually helping us is these diagrams are nothing but the plots between delta G and temperature. So delta G we know is nothing but the Gibbs free energy which acts as a driving force, thermodynamic driving force for any particular reaction to occur. And T is the temperature. We all know that the equation for this delta G is as follows. Delta G is nothing but delta H minus T delta S, right? This is the equation that we have. Now, if you carefully observe from the given point of a Lingam diagram, this looks as if it is Y. This is some constant C plus mx, correct? What is this? This is nothing but an equation of a straight line, right? So a Lingam diagram, which is my delta G versus T, where delta G on y-axis and T, the temperature on x-axis, you get to see different lines like this. Okay. Now these are different oxidation reactions. Remember, all these are actually studied for oxidation reaction. Let me take two examples. Let's say I have A plus half O2 is converting to AO and B plus half O2 is converting to BO. Now, let's say these are the two different oxides, okay, of metals A and B. What these lines signify, what these two lines explain us. So it is very simple. It explains about the ease of reduction, or it explains about the stability of a particular oxide. How? So we know that delta G should be minimum for higher stability. That means at any particular given point of temperature, okay, that means at any given temperature, the oxide which is lying on bottom, that means the line that is lying on the bottom side is more stable oxide. Why? Because it has the minimum Gibbs free energy. So in that point, Ellingham diagram will tell you which oxide is most stable or which can easily form. Okay. So not only that, there are two important lines that you have to remember. One is a horizontal line which you will see, which is formation of CO2, carbon converting to CO2. Similarly, there is one more special line which has a negative slope, which actually is the formation of CO. Okay, these two are very, very important lines. Rest all lines, that means rest all oxidation reactions of any metal have a positive slope only. That is the reason why if you take any particular metal, oxidation reaction at some or the other temperature, you can see that the carbon line is actually lying below the metal oxide. That is the reason why we use carbothermic reductions. One of the best example is nothing but the iron making blast furnace, right? We use CO, I mean, we produce CO in the 2-year zone so that it can reduce my iron oxide, which is somewhere here. Now, coming back to the question, how this concept can be used is nothing but just look at the original Lingam diagram. So, maybe if you look at it, you can see that calcium is the most stable oxide. Okay, that means calcium can immediately easily oxide. In other words, I can say that calcium Lingam diagram, in the Lingam diagram, you can see calcium is at the most bottom. Okay, and if you go slowly on top of it, what happens? You'll find magnesium, aluminium, titanium, silicon, manganese, and slowly as you increase the delta Z, you finally have carbon and phosphorus. So here in steel making, in basic oxygen steel making, which is nothing but my primary steel making, the order of oxidation is something like this: silicon, manganese, carbon and phosphorus. So this is what is the order. Of course, carbon and phosphorus are simultaneously, oxidized out also in some favorable conditions. But that is not the point of this particular question. It is asking what? It is asking which will oxidize first. So the answer would be silicon. So with the help of the Illingham diagram, you can find out which material or which element will oxidize easily, or which material can be used as a reducing agent to reduce a particular oxide. So this is the concept of Illingham diagram through which this question is solved. Thank you.